Next, we have boundary analysis and soft data assembly. Within rmsp, we use rmsp.contacts to inspect the contacts, define soft boundaries, and also to manage the data so that we can calculate and retrieve soft data for each one of the domains. The way we set up the contacts class within rmsp is by providing the data, which are our composites, providing the categorical column that we want to calculate the contacts for. In our case, we have a grade shell with 2 domains, so we are basically looking at one contact. If I take a look at the arguments of this class, I see that we can provide a subset of the categories. So if we do not want to calculate contacts for all the categories, we could provide a subset here. Otherwise, it's just going to use all the categories. The next 2 parameters here are the distance and the number of steps. So this distance and number of steps will define the bin size around the contact that we want to use. For instance, we are going to look as far as 50 meters from the contacts with 10 steps. So that means that each bin on my contact plot is going to represent 5 meters. If I go ahead and run the cell, on top of initializing the contacts class, it also generates a figure, which is the usual figure that we want to look at. Notice that because our contacts are only for 2 categories, I'm using the method called contact plot. In case of a categorical variable with multiple categories, if I want to look at all of them in a single figure, I would use contact plots. So that will generate a plot for all the contacts. But in our case, both contact plot or contact plots will generate the same result because we only have 2 categories and 1 contact to look at. Let's take a look at the elements of this plot. As I said, we have the contact in the middle, and we have a histogram like of the average grade within each bin. And each one of these bins are represented or defined by the distance and number of steps. So for each one of these bins, we have 5-meter intervals. And we can see that the bars represent the maximum count. In this case, it is represented as a fraction of the total. This could be controlled by this function if you want to see the actual data count within each bin. The bars are colored by the domain color. So the outside is gray and the inside is red. The line we see is the average grade within each one of these bins, and the value is shown on the y-axis, which is the average gold grade for each one of these bins. So as we can see, on the outside domain, we have low grade. It slightly increases towards the high grade shell. And we also see that we have this dotted line. The dotted line is for the average value within the outside domain or within the domains. So we can see that the average value for the outside is much lower than the average value for the inside. Notice that it might be beneficial to have a legend that explains that the dotted line is the global mean and the solid line is just the average grade within each bin. So in order to add a legend, we can just do axis.legend, and this will add a legend to the plot. Now that we have looked at the contact plot, we can define soft boundary parameters. So in order to do that, the format that we use is a dictionary, and the key of the dictionary defines the domain that we start from to the domain we are getting into, and then specify a search with a certain range. So in this case, we are saying that we are seeing a soft boundary going from the outside domain, so starting from the outside, into the inside domain by a total distance of 10 meters, so around here. So we are saying that there is a soft boundary going into the inside shell from the outside shell of 10 meters. So we can go ahead and run this cell. And the way we set this information into our contact object is by calling contacts dot. We need to specify the variable that we are setting this contact for, because this class is designed to handle multiple variables. In this case, we only have gold, but we could have had other variables. So I need to specify the variable I'm setting the contact for and provide the dictionary with this particular structure. And we can decide whether or not we want a symmetric contact. Let's start with non-symmetric. So let's set this to false. And now run this cell. So you can see that we have set this contact going from the outside to the inside domain by 10 meters. At this case, we have not set the symmetric to true, so we do not have a soft contact going from the inside into the outside domain. If we go ahead and set this to true, then now we are gonna see the contact both ways. To set up a asymmetric boundary, we need to go and set this to false and specify one more entry in here. And let's say that we want a larger soft boundary going from the outside from the inside into the outside, and we can get the asymmetric soft boundary. Let's go back to what we had before and go from there.